Hello everyone, welcome to Kroll's weekly threat intelligence briefing for the 22nd of September. My name is Ryan Hicks and joining me this week is Mukesh Nagar and Ethan Afuri from the threat intelligence team. So this week I will be covering a worm named Shai-Hulud spreading across developers in a supply chain attack on NPM. Mukesh will be covering a North Korean APT using deepfake false IDs and a UEFI ransomware known as HYBRIDPETYA. And Ethan will be talking through several frameworks seeking to use AI for post-exploitation. So to begin here, a widespread supply chain attack has been discovered targeting developers and users of Node Package Manager or NPM. The malicious code used has been dubbed as Shai-Hulud based on the name of the repositories that it creates in GitHub. The activity is significant compared to previous NPM attacks in that it is an information stealer that also acts as a worm, spreading by itself to new victims to greatly increase the scale and potential impact of the campaign. The details of the first victim developer or how they were compromised is unknown. It is, however, likely to have been a developer with access to multiple popular packages, likely similar social engineering techniques through phishing, as we've previously reported that they first got attacked. The campaign so far impacted over 700 packages in total, including some popular ones, so TinyColor, NGX Bootstrap, several CrowdStrike packages as well appear to be impacted. For affected packages, malicious code was added to perform various post-install actions, and so these kind of malicious actions occurred once a user had downloaded and installed the package that had been changed. So firstly, the tool called TruffleHog was executed, and that's a legitimate open source tool used to scan for over 800 secrets or credential secrets. So things like NPM tokens, GitHub keys, Amazon Web Service keys, and a huge range of others that it was basically searching for. And if GitHub credentials are found, it will look to create a public repository under that user's account and post system information as well as the rest of the secrets it found into that repository, which is the image on the right there you see. At the time, there's kind of a reduced number, so only 26. So clearly people were noticing the repositories being created under their name and removing them or making them private before removing them. But clearly there were some that were kind of still out there, and those contained sort of clear text secrets. It was also observed creating workflows inside repositories where a curl command would send secrets to a malicious URL, so essentially back to the threat actor. And if any NPM tokens are found, these would be used to update additional packages with its own malicious code. Again, that's that kind of worm spreading feature. So additional users would then download and be affected, so it kind of spread from there. And the publicly visible impact really is limited to the leak credentials for those services. However, due to them being publicly available in some cases, has the potential to additionally compromise through the reuse of these secrets by anyone who has access to that information. So potentially they could pick up on those secrets and try and gain access to the organization or the data in that way. So really recommendations, so developers checking for potential compromise in terms of kind of looking for those GitHub repositories, as well as any private repositories that were changed to become public. That was another thing that the tool did. Any NPM developers ensuring checking for any unknown updates to the packages that maintain, and due to the kind of main pointing the secrets gathering, if any signs of compromise are seen, ensuring re-rolling of secrets if compromise is suspected. With that, I will hand over to Mukesh.
Thank you, Ryan. South Korean security company Genians have released a report detailing the use of artificial intelligence tooling by North Korean threat actors to target South Korean entities. The campaign was discovered in July 2025, but shows that phishing campaigns started in at least June of 2025. Campaigns targeted those mainly in the defense community, researchers of North Korea, journalists. The threat actors generated fake images of military government employee ID cards with ChatGPT and launched a spear phishing campaign. disguised as a draft review request. An operational security mistake kept the metadata in the image showing that it was indeed generated using ChatGPT. According to the security research company, 3 distinct campaigns were launched via spear phishing. 2 campaigns leveraged clickfix and fake capture style pages to cause the victims to install malware, whereas the 3rd campaign used spear phishing and a lower website which incorporated the fake IDs. That campaign leveraged obfuscated scripts through the tools like PowerShell and Auto-IT and CAB and .lnk files to execute additional payloads, which is consistent with previous KTA 082 phishing campaigns that we've observed. Persistence is achieved via scheduled tasks designed to emulate the Microsoft App Store process. Now, moving on to some UEFI ransomware. ESET Research found malware samples with file names similar to PETYA and NOTPETYA malware strains named HYBRIDPETYA. The new samples incorporates capabilities for compromising UEFI-based systems through utilizing a vulnerability tracked as CVE 2024-7344. CVE 2024-7344 allows for the execution of unsigned software in the HYBRIDPETYA UEFI application. The malware can install a malicious extensible firmware interface, so EFI application, into the EFI system partition, allowing the malware full access to the system before the Windows operating system is loaded. Indications from the samples shows the purpose of the sample to be a regular ransomware rather than purely destructive nature of NotPetya. At the time of writing, ESET researchers has not found any active use of HYBRIDPETYA in the wild. Updates to the HYBRID Reloader software and Microsoft Forbidden Signature database have been made available for some time. Any organizations using HYBRID Reloader UEFI applications should make sure that they are appropriately patched to prevent exploitation. Back to you, Ryan.
Thanks, Vikesh. Finally, Ethan runs us off looking at several tools using AI.
Thanks, Ryan. A new powerful AI hacking tool called Villager has appeared online causing concern among cybersecurity experts. Developed by a mysterious China-based group named Cyberspike, the tool was made freely available on the Python Package Index, or PYPI, where it was downloaded nearly 11,000 times in just 2 months. Described as an AI-powered successor to the notorious Cobalt-Strike framework, Villager automates complex cyber attacks by integrating Linux toolsets with DeepSeek AI models. This allows an operator to issue simple natural language commands like scan and exploit a website. The tool's AI then orchestrates the entire attack, breaking the request down into technical steps and executing them autonomously. What makes Villager particularly dangerous is its sophistication and stealth. It automatically creates isolated Linux containers for its operations that are designed to self-destruct within 24 hours, making forensic analysis incredibly difficult. The AI can also dynamically adapt its attack structure in real time based on the target environment, increasing its chances of success. The group behind Villager, Cyberspike, has a questionable history, having previously repackaged known malware like the async rat remote access Trojan into its products. This has led experts to warn that Villager will follow the same trajectory as Cobalt-Strike, a legitimate penetration testing tool that became a favorite weapon for cybercriminals and nation-state hackers. The core concern is that Villager dramatically lowers the barrier for entry, enabling less skilled actors to launch advanced automated intrusions with unprecedented speed and efficiency. Its emergence signals a major shift toward what some are calling AI-powered persistent threats, or AIPTs, a new class of autonomous cyber attacks that can plan, adapt, and execute campaigns at scale. Next slide. Thank you. For a long time, post-exploitation has been a time-consuming manual process. Attackers relied on tools with significant drawbacks. For example, credential hunters like Trufflehog use regular expressions which are inherently limited to known formats and can easily miss unconventional plain text passwords. This leaves major gaps in coverages. Early attempts to use AI also fell short. Spectre Ops DPass was a powerful idea, but it required operators to first identify and download all documents before analysis could begin. This dramatically increased operational risk and noise. Other tools like SharpML tried to run on the target, but they wrote models and other components directly to the disk, making them easily detectable by security software. But this has changed thanks to two key advancements. First, modern Windows versions now include built-in AI and machine learning APIs that can be accessed from native C++ code. Second, frameworks like Cobalt Stripe's Post-Exploitation allow for the creation of tools as DLLs that can be reflectively loaded and executed entirely in memory. By combining these, it's now possible to build fully in-memory AI augmented tools that analyze data directly on the target system, leaving no disk artifacts. Proofs of concepts like credentialfinder.dll can classify passwords with high confidence at runtime, while semanticsearch.dll can perform contextual natural language searches for high-value information going far beyond simple keyword matching. This represents a massive leap forward, making post-exploitation stealthier, faster, and more intelligent. Thank you, Ryan.
Thanks, Ethan. So that's all we have time for this week. If you have any questions, please contact us at cti@kroll.com. Thank you for watching, and we will see you next week.